Selamat pagi, salam sejahtera untuk kita semua. Our respected Miss Deepjyoti as Senior Product Success Manager Bentley System. Our respected Jamie Howe as Product Sales Engineer Bentley System. Yang saya hormati Bapak Junius Halawa as Application Engineer Solution Engineering Bentley System. Yang saya hormati dan saya muliakan Bapak dan Ibu peserta webinar, baik dari PDAM, kontraktor, dan konsultan. Alhamdulillahirabbil alamin, tentunya puji dan syukur kita panjatkan kepada Allah Subhanahu wa taala karena berkat karunia-Nya pada pagi ini acara webinar dapat terselenggara. Perkenalkan, nama saya Nesi dari PT Kurnia Handasa Nevada Bentley Channel Partner Indonesia. Sekilas tentang KHN, kami adalah Bentley berpusat di Amerika, berfokus pada pengembangan engineering software mulai dari perencanaan, desain, konstruksi, dan pengelolaan infrastruktur. Salah satu bidang yang menjadi perhatian Bentley adalah sektor sumber daya air. Terima kasih yang sebesar-besarnya kami haturkan kepada Bapak dan Ibu yang telah berkenan hadir. Tentunya ini merupakan suatu kehormatan bagi kami. Bapak dan Ibu, tema besar 3 series webinar kita adalah Smart Water Loss Management 24/7 Supply Resilience. Tema pada sesi kedua hari ini adalah Real-Time Operational Intelligence atau yang kita kenal dengan Digital Twin. Sesi ini akan menampilkan bagaimana integrasi data SCADA secara real-time, di mana memungkinkan operator untuk mendeteksi anomali sistem, seperti pecahnya pipa secara tiba-tiba, serta memantau data sensor secara langsung. Hadirin yang terhormat, kita akan memasuki sesi materi pertama yang akan dibawakan oleh Jamie Howe, yang akan memaparkan overview untuk Open Flows dan Digital Twin. I'll now hand it over to Jamie.
Thank you so
please.
much, Bu. Thank you. So, selamat pagi, Bapak, Ibu. Good morning, everyone. Let me share my screen quickly. Let me know if you can see. Yeah. So, welcome back again to this webinar series on smart water management and 24/7 supply resilience. Last week in part 1, we looked into how utilities can reduce non-revenue water through leakage detection and pressure management. And this week, we are in part 2. In this session, we will take one step further, exploring how you can move towards real-time operational intelligence using digital twin. Okay, so here. So when utilities or water bodies or agencies have models and data in place, many operations are largely still reactive. This means that, okay, apologies everyone. We would appreciate it if you could mute your mic. Yeah.
So, Bapak dan Ibu, dimohon untuk mode mute ya. Terima kasih.
Thank you, Bu Nesi. Thank you. So for water bodies, many water bodies still have the models and data, but many of their operations are still very reactive. Reactive meaning that the decisions that are made are often based on either historical data or periodic inspections rather than real-time conditions. This makes it difficult to detect issues early, difficult to respond quickly, and also difficult to optimize the system performance in overall. So the question becomes like, how do we move beyond just a static model? This is where the concept of digital twin comes in. Digital twin connects your hydraulic model with real-time data from the field. And this allows you to monitor, to simulate, and respond to the system conditions as they happen. It shifts your operation from just reactive to more predictive and proactive. And one example here is in Singapore, where PUB, Singapore's National Water Agency, manages an extensive water network of over 6,000 kilometers. Traditionally, even with monitoring systems in place, leakage detection and anomaly identification still required a significant amount of manual effort. So by using OpenFlows together with iTwin and integrating monitoring data with AI and machine learning, PUB developed a high-fidelity digital twin of their network. And as a result, this enabled automated anomaly detection and allowed them to identify and localize underground leaks much more quickly. And they were able to shift from time-based inspections to data-driven proactive operations. So what exactly is digital twin? At the left side here, you can see it is a digital replica of your water network, which is continuously updated with real-time data and combining your hydraulic models with field data from sensors and monitoring system. And more importantly, is on the right here, is what it enables. It provides you real-time visibility of the system. It allows early detection of anomalies. It enables faster response to issues. So ultimately, this will help improve your overall operational efficiency. So instead of working with static models and delayed information, you can move towards real-time predictive decision-making for your water network. And as we have seen, digital twin, it enables real-time visibility and more proactive operations. But to make this work effectively, it requires a reliable hydraulic model as the foundation, together with the ability to work with real-time data. And this is where OpenFlow's solution comes in. And for those who attended part 1, you may have seen this slide before. This shows that OpenFlow supports modeling and analysis across water distribution, wastewater, and stormwater systems as well. And solutions like Hydraulic Toolset is also available for component level analysis, and OpenFlow's Flood for more advanced flood and risk modeling purpose. And this slide shows that in OpenFlows, we offer different tiers so that you can select the option that best matches your requirement, your project scope, your operational needs as well. This ensures that you are using a solution that aligns with your network size, your level of complexity, and your budget. And today we are focusing on OpenFlow's water. So this slide here gives us a closer look on the capabilities, how it expands across the different OpenFlow's water tiers. So as you move across from left to right here, you're not just increasing the model size, you're also unlocking more advanced capabilities such as transient analysis, optimization, and integration with real-time data through SCADA. So these are important when moving towards digital twin applications where both simulation and live data need to work together. And we'll run through quickly on Virtuoso Practitioner License. So Virtuoso subscription is a subscription available in our Bentley eStore or our e-commerce platform. So this is a flexible solution because anybody can purchase a Virtuoso subscription. Whether you are an individual or you come from a small or large organization, you can always purchase a Virtuoso subscription. And it is also flexible because it is a 12-month subscription without any renewal commitment required. If your project is or your scope of work to use the software is only for 2 to 3 years, then you can stay subscribed to the software for 2 to 3 years. And after your work has ended and you do not need the software anymore, you can just choose not to renew your subscription. And lastly is the keys that come bundled with trainings, which help you unlock different types of free customizable trainings. And how it works is that if you purchase a Virtuoso subscription of OpenFlows, for example, the purchase of a license comes bundled with keys, which help you unlock different types of trainings. All these are online trainings. It can be live with our technical expert through training on tailor-made training programs or mentoring services, or it can be on demand, which is recorded sessions where you can watch it at your own time and pace for a period of 90 days. The number of keys also varies depending on the product tier that you purchase. So this is the number of keys that comes with a license for OpenFlow's water. The two lowest tiers, essentials and standard, it comes with 1 key per license, and for advanced and ultimate, 2 keys per license. 1 key is almost 2 hours of free training that you can redeem. So in summary, Virtuoso practitioner license is a license with name user that can be reassigned. This is a yearly investment without any additional maintenance costs, so that you can have a better control of your software costs every year. And throughout your whole active subscription period of the license, you can unlock free technical support assistance, free software updates and upgrades if there are any new releases, and also, as mentioned just now, expert services that you can redeem using keys. And if you need further information, feel free to reach out to Bu Nesi or PT Kurnia Handasa Nevada. They are one of our channel partners here in Indonesia, and we are happy to work together with them to assist you in any inquiries that you may have. So that's all from my end right now. Thank you so much. And I'll hand over it back to you, Bu Nesi. Thank you.
Thank you, Jamie, for the
Thank
insightful
you.
presentation. Okay, now we will move to our main session, delivered by our keynote speaker, Mr. Deep Jyoti, as a Senior Product Success Manager, Bentley System. Deep Jyoti, floor is yours. Thank you.
Thanks. Thanks, Missy. Thanks, Jamie. Thanks, everyone, for joining the session today. And also, last week we have done the first session of OpenFlow's water. And this sessions I will discuss about the real-time operational and also intelligence with the digital twins. So let's just, could you please confirm that my screen is visible or not?
Yes, it is, Deep.
Okay, one second. Okay. Last week we have discussed about OpenFlow's waters, how you can do that, the modelings with most optimizations and also DMS strategies, leakage detections, and multiple features, right? But what is the next? So we have already built the networks and do that optimizations things, but the next is where that challenge also comes. Imagine that if we could solve some of the toughest problems challenge, as an example, I'm saying that the utilities faces average losses of 25 to 40% of drinking waters. Okay, so energy usage and costs are up to 30% of the utilities operations budget. So how you will maintain all these things? So next parts comes with that operation and maintenance, O&M. That involves lot of different strategies with how we just connect that OpenFlow's waters and also do the SCADA integrations. But just one point to highlight that except OpenFlow's waters, we have multiple products. So for your complete life cycles, for pipe networks, water treatment plants, for wastewater engineering, for storm waters, there are different applications we have. Okay, but now we will discuss about digital twins on potable waters only. Okay, so here I will discuss about not only that OpenFlow's waters integrations, but how I will help you with the capabilities of GIS integrations and model integrations together, and how you can work with a collaborative environment. Okay, so the overall challenges in water industry is like you need to reduce the funds, control the operating cost. You have to go with water qualities and regulatory compliances. Different places has different compliances, and that is one of that important point. You need to predict the demands and optimize the productions. You have to check the water losses and the critical business issues like safety and that environmental issues, the operating cost with like you have to reduce the energy cost and also carbon dioxides like carbon footprints, and also you need to reduce the downtimes. You need to manage the informations in different systems, like manage different informations for ET, IoTs, and IT data, customer billing informations. Okay, so the challenge is not about collecting the data. So the challenge is what that has been very hard to pull together informations from engineering modeling systems, the maintenance systems, the ERP systems, the SCADA control systems, and also as well as some historical data. But all this could be done with open flows of water and also water site applications. So we'll talk today about this digital twins. Okay. So the data may be like, it may be like unstructured and in silos, but in open flows applications, you can create the digital twins with using all of that like GIS informations, the designs, approach, the constructions information. So together in a cloud platforms, you can create digital sets. Okay. So just to highlights about few points, like here I will discuss about the SCADA and the advanced applications of the SCADA with water site. But open flows water has the capabilities for the leakage reductions to pressure control, water safeties, capital investment plans. It can help you with the master plannings and also energy efficiencies and real-time operations with models, emergency responses. Okay. So just have a look on the, so this is like how we design, build, operate, and maintain. Okay. So the water systems digital twin involves integrating the virtual engineering models with city scale reality models and also geographic information systems data. And also additionally, you have to go with the digital twins are continuously updated with virtual operations data from SCADA systems. You may have the sensors too, meters and other measured sources, and creating a real-time model that can be used in operations. So a digital twin is actually a dynamically changes based on the data it receives. So you are working in a real-time data. So it allows it to just mature and yield valuable informations that is not generated by the traditional static models. Okay, so we created the models, but the now thing is that with the we create the digital twins which will be continuously updated with the real-time status, and that capability can drive the business decision. So you can take the right decisions in that right times, that if there is any leakage, so you can visualize the networks, you can go get the insights, where there is the leakage, where is the low pressures, everything, every performance you can do. You can make the asset performance with this all that GIS data, weather stations data, hydraulic models, integrations. So this will come together in a single platforms. Okay. So, but before going on that, I would like to highlight about the hydraulic modeling and the SCADA system. So this is where the power of Bentley open flows water comes in. It can fill in the gaps of information between sensors reporting to SCADA systems. And realistically, you don't have to go to the pressure sensor installed at every corner on every street. But you do have a hydraulic model, and you can use that to determine where the high or low pressure exists, that I have already talked about. Okay. So in the system or the project system performance into the futures, so you can just predict also. Okay, you can go with the SCADA's information. So like pump information. So if we supply the hydraulic model with live data, you can see when and where there may be a problem before it occurs. Okay. So how the system architecture actually looks. So from that SCADA's system, it comes to the OPC servers. And from that, with this OPC servers, we connect with the SCADA Connect simulators. So here is the Bentley interfaces with that SCADA Connect simulators, and you can directly get all this information from this OPC server here with that sensors data, right? So just have a look at quick videos that here how we just configure the SCADA signal. So you can just put this SCADA signals from that layout tools and put with the SCADA Connect simulator. So here with the SCADA Connect simulator, you just make this SCADA signals with the different data sets. Here you can choose that with the historical data also. You can go with the different data. You may have some SQL data or like OPC servers. So this is important that how you are just connecting the data from your data loggers. Here you can go with the signal names. Sorry. Okay. So you can go with the signal names and the alerts, and the interface is very simple and can be used with the operators too. So you just refresh it, it will give you like that the stuff from starting points to end points data. Okay, and very quick. So here is that view of this signals from that the servers we have connected here, SCADA signals. Now let's see another example of the, as an example I'm just showing here is a fire event simulation. So this is like different, like you can go with the fire response, pipe breaks. Okay, so I would like to check that the fire is and to simulate the emergency situation such as network breakdown and repair power outage for the fire event. So you can directly go with that 2000 GPMs. So it will directly show you that what is that flows and the graphs, how it's changing with the times. So it's getting or not. So everything you will get to see with that hydraulic rates, it's changing. Okay. So you can create that different responses and different alerts. Okay, so the thing is, similarly, you can create the pipe burst simulation. So this is OpenFlow's water interface. In the background, you can get to see the ping maps, the different scenario also. Like we have done with the SCADA, we have connected the SCADA system at last. So you can create a new scenario with SCADA Connect simulators and creating a new scenarios with that signals. Okay, you can just run with that historical simulations and also live simulations. It may have that you have no that OPC servers or you are not going to connect that one. So that is the thing you can create. Okay, let's have another example of pipe burst. So define the best actions when responding the emergency. So you can go with the leakage flow, just put that the pipe response when the leakage flow will show you, and you can just run with that breaks with that isolations valve. And if you just click on that isolate, it will automatically just make that customer meters with that valves isolated against this pipe breaks. So if you just run it, and you will get to see that the nodes and also that I mean the junctions and also the customer meters which are affected by this pipe breaks with a different time. So you can just, so here you will get to see this color is changing for these areas. Okay, so now if you just go with the customer meters, here you will get to see that the which customers are at most risk. Okay, for this pipe breaks. So you have already put this isolation valves and also that the sensors with that pipe breaks and GPM. So select the save options to improve network resiliency. So you can do that the symbologies and can run that burst events, and it will directly show you that again that in which like in different times how it behaves with, okay, or different isolations. Okay. You can view the results of the SCADA, and you can export the model results in human machine interface, where you can get to see directly as an HMI. So as an example, I'm going to put the what is the pump curves and what is with the junctions pressures. So here I have just put that pump flows, the node pressures, and what is the tank level. So everything I would like to make one of that HMIs. Okay. So here in this what are the SCADA simulators, you'll get to see that HMI where it comes as a dashboard type of things where you just run it and move the time browser now. So here is that the tank labels. It's coming. So if you just move the times, it will change automatically. So all that features of that the pump flows, the pressures. So you can also do more about that. Nothing like this is fixed with these 4 variables, but you can also make the export the results and can create all this like Excels and make the Power BI reports too. Okay. There are also a lot of case studies we have regarding SCADA's Connect. So you can just have a look in our websites with different regions Okay, so also in Philippines, there is Manila Waters. They have used SCADA connector for that optimizations and also real-time modelings. Okay, and also in Singapore, they have used. So there are a lot of case studies we have. You can just have a look on that. I will discuss one of that in a later on. Okay, so now this is the SCADA systems, and next is that updated with the water sites with the digital twins operation. So you can bring together the engineering data, the operation data, and information systems data in Evergreen Digital Twin model that is consistently updating. Okay, so with all these data, you can create one single platforms where you can get all these multiple data as an like you can get to see the networks, you can get to see the alerts, the numerical models in the backgrounds, the maps, GIS data, different pressure zones, customers, sensors, everything, it will come in a dashboard. So this is the digital twin administration's menus, and where the users can configure the digital twin of the network, connections to other systems, and several different settings like Power BI customized dashboards, and also make alerts, configurations, and those um, general settings. Okay. Uh, so the thing is, how actually OpenFlow's water, so with that water sites help with this digital twins. Uh, in OpenFlow's water, you can do water balance with the DMS, pressure management, leakage detections, and also do the capital plannings. But with these digital twins, you can also improve the real-time insights and awarenesses. You can go real-time anomalies detections of events using AI such as burst, leaks, fires, and you can just identify more failures, the awareness about the anomalies in the events. You can improve operational cost. You can reduce the water losses. I will show you that how you can create the automatic computations of volume lost in each event. And also you can make the current and future performance. You can predict, compute, analytics using hydraulic model and machine learnings and advanced algorithms. You can improve the business process where uh, operators, engineers, or a network modeler can work together in a common environment. Okay, it's like smart platforms. So this is not limited with the engineers. You can just give the access like user IDs to the operators, and anyone from anywhere can check what is the current status, even from mobile too. Okay. And you can monitor each pump efficiencies, compare with the best efficiency points, energy inefficiencies calculations for each pump you can do. So this is with this OpenFlow. So water and with that advancement with digital twins integrations, I am showing in the next slide. So you can integrate the WaterGems models, like the synergy between WaterGems and WaterSide make you that actual digital twin. Okay, so where you can just put these models in that digital platforms and where you can make the okay. So what is the actually makes it this digital twins? So what we creates. So you can make like the GIS databases, the hydraulic models, instrumentations you need, SCADA data, client informations, and historical failure data. And with AIs, you can create the digital twins. So you may have some questions that what data you needs. So, but obviously that the census information is needed for that real times. And that's why you can easily visualize up-to-date data trends from SCADA and hydraulic model. You can make seamless collaborations across department boundaries, understand and proactively mitigate the impact on demands based on forecasted weather patterns. You may make better informed asset integrities also. So now there are a lot of challenges previously it has, but that is why that OpenFlow's water site was there. Okay. So the first challenge was when it comes to building and maintaining digital twins, many utilities are faces with data overload. Okay. So they have mountains of disparate data from different SCADA sources like meter informations, billing records, GIS systems, and so on. So most of them don't talk to each other. So accessing that dark data can be difficult. And in the middle of an operational crisis, the last thing someone wants to do to go hunting for the right data, or trying to piece things together from different sources. Okay, so that's why the that open flows over waters with that water side integrations comes. So the other major challenges for utilities, the systems are very complex. So everything is interconnected in the systems like pipes, tanks, pumps, valves, and so on. So as well as to external factors such as weather events, maintenance, constructions. So increasing that complexity, there are many different types of people. So when you can introduce complex tools behind the scenes, you can facilitate making it simple. Okay, so first, decisions in operational situations. So this is how it actually makes together all in that open flows water site. Okay, so from network monitoring, so you get that real-time flows, pressures, level monitoring detections from the SCADA data. So you need have the pump information, tank performances. You want to make that also like water audits and automatic mass balance. Okay, so as per IOA, you can also do that water balance and also go with the emergency responses with the real-time data. So all how you can do, so you just put hydraulic models, GIS data, SCADA automations, that EAP, EM informations with the commercial systems, IoT's data, so weather stations informations. So all things comes in a single cloud platform. So here, look at how it actually looks. So this is first how you start with that waterside website. So you just put your email IDs and just log in on it, and you'll get to see the first dashboard with all that users of like how many network alerts is there, pumps information, tank informations, and you can also change this dashboards with the much more informations. Okay, so you can identify the leaks with that anomalies. You can compare real SCADA data with the expected behaviors, and also enter you can choose that where is the anomalies and can just get to see that, make an event on that. So someone from different team can also check that what events you have created. You can get to see that the zones, different zones, and here is that how we have created DMS previously. Okay, but here you can also make the advancement of that. So with the real-time data for each zone, what is the pressures, what is the, it's a in the, you can also identify the leakage. Okay, for that night minimum flows. Okay, and not only this, you can just go with that different zones and also different patterns for the what is the for the last month's volumes, and you can predict for the next months too. So if there is maybe any failures in the future, so you can also analyze the pump performance over the times. With the pumps, it comes with the tanks also. You can analyze the levels of the tanks, okay, with the real times and historical data, and compare the measurements between the different tanks with different zones. So thus you can create the also how that NRW's detections strategies actually work. You can create the events here, okay, and can make this and just make the comments, so someone else can also check and can see that, okay, there is a 5 burst events maybe, and they can just make a decisions on that. You can go with the automatic water balance calculations according to the where. Okay, so I will show you in the next slides in details that how it actually goes with comparing water balance volumes, and also you can just go with the zone with the highest volumes and water losses corresponding to the zones with lowest percentage of the losses. Okay, so you can go with the different zones, not only just going to the networks models and checking, and you can understand the evaluations of water balance components along the time. So what is the real losses? What is the cost? So everything for that NRWs you can calculate for different as per the different zones. And this is the integrated view with water giants models, combining SCADA data with hydraulic models. So you can just make this above the Bing maps with that GIS maps, and also create this as part like what you are creating, like hydraulic grade line based or that pressure based, everything you can make on, and with the isolations valves, which emergency response simulations make this, which area will be affected, that also you can get to see the live data, right? So here is that information of that all that informations we have used. So you can also attach much more. So this is like few of that things with the census data and that settings. So this is like dashboards with the Power BI reports you can create, and you can just change, and no need to download it, because anyone you can share with that the credentials, and anyone can see what's happening there. Okay, they can also customize the reports and can also create your own report. So so the thing is, how much you can save with this digital twins platform. So the main point is that you can support the NRW reduction, support reductions of pump energy cost, reductions of field pump testing costs, reducing SCADA infrastructure cost also. So SCADA is one of that in that open flows of water, but with the advancement, with the direct, you can also do this OPC servers with the signals here. You can make that how the smart capacities with the plannings. Okay, so this also has a lot of case studies. Okay, and you can also improve the awareness and operational responses. Okay, with different applications for that. And so this is here I have just make this time arrange for the 3 months. Okay, so here you can make this for like what is burst, and can make this comments one and maximum values, and also volume. So everything in detail you will get to see in this results. Okay, so you can simulate the impacts of the events and can check with the telescopic ranges. Okay. So there are a lot of case studies it also has in our websites too. I will share some of the case studies links, so you can also get to see. So just I am changing the here the zones, and it's changing with that. So this is like how that water balance volumes and percentage between the different zones. So you can create. Okay. So moving the cursor, you can get to see that's volumes, and you can create the graphs accordingly. So you can go with the current and future performances that I have already mentioned you. So with the SCADA data. So from the flows, from the pressures, you can color code and make it like just the color will change with the times and create. Okay. So what's your but for this we need OpenFlows water models in the backgrounds. So OpenFlows water is a basic thing, and next this is an advanced one. So this is one of the case studies for cities. So it's responsible to the all water cycle managements for water treatment, water distributions. And the main challenge was that they had more than 20 different systems to manage all the operations and operators. And operators are non-engineers, and they did not have the access to these systems. So that was too complicated. So we have built one of that single platform, simple and user-friendly, that could be used by anyone at the utilities. So we brought this digital twin technologies with this OpenFlows workers thing. So that helps them to manage and also do the maintenance parts. Okay. So 1 second, there is just another case studies is here. This is in India, orange cities. It's in Nagpur city. So this is for the 24/7 analysis they have done for an uninterrupted water supply schemes. So that's very famous of that water schemes comes from that one sign. And in 24, they have implemented that digital twins applications in Nagpur cities. But this is actually for the whole cities they have. And the full cities has implemented it. And this project was highlighted and also get hugely famous because of this, like the digital twin integrations, and with all the data stored in different systems like GIS, SCADAs, they have created water balances, water systems insights, and also the pump to tanks. So it's working in with the real-time data. Okay. it can forecast, it can predict where maybe pipe burst, where maybe some alarms and everything. So the real-time models of the systems help them to understand where is the how the DMAs are actually affecting with the low pressure zones, and also helps them to foster the interdepartmental collaborations with operators and also the engineers. You can also have a look on these digital twins in our websites, and that has we have a lot of case studies there too for Southeast Asia and also for global users. I am finishing my slides here, so if you have any questions, please feel free to ask me. Yeah.
Thank you very much, Deep, for your detailed and insightful presentation. We truly appreciate the knowledge you have shared with us today. Hadirin yang terhormat, sekarang kita akan memasuki sesi tanya jawab. Pada sesi ini akan dipandu oleh Pak Junius sebagai Application Engineer Solution Engineering Bentley. Kepada Pak Junius, dipersilakan untuk memandu.
Terima kasih Ibu Nesi. Apakah suara saya terdengar, Bu?
Terdengar jelas?
Oke. Bapak Ibu sekalian, terima kasih sudah bertahan ya mengikuti sesi webinar hari ini. Bapak Ibu kalau misalkan ada pertanyaan bisa disampaikan langsung dengan bisa pakai bahasa Inggris atau bahasa Indonesia, nanti saya bisa terjemahkan untuk sampaikan ke pembicara kita. Ya, silakan Pak Rido.
Thank you so much for Deep to explain. It's really interesting to understand about the OpenFlow. My name is Rido from Indonesia, and then I'm working currently in water for industry, especially at the water drinking company in Jakarta. And then it's very interesting to understand about the integrated all of the data that you mentioned previously. I curious about the non-revenue water that you mentioned before in your presentation, that we are able to understand about the how many water that leakage from our pipe system, and then can you explain to us how we integrated to take action from that data to a real project. For example, okay, in our data, there is any leakage or non-revenue water indicated on our SCADA in area of Norton, and then how do we understand in the real life where is the location, and then how we prepare the project, and then etc. etc. Maybe if you can explain more, it's very advanced for us. Thank you. Maybe that's all from me, Pak Junius.
Okay, thank you. Thanks. Actually, SCADA data and NRW are that you are saying, like how we can do this in SCADAs. So with the SCADA Connect simulators, that tool allows you to map real time, or if you have historical data from the sensors or the databases, or maybe with the OPC servers directly to the model elements like pipes, tanks, pumps, to compare what is the simulated data with the hydraulic results in the actual field you get. So that is the OPC servers or the databases or the sensors data that can be directly just make the OPC servers, you do the connections, okay? And from that, you will compare those with the model data. And with that, you can just make the what is the inner Ws on that, okay? So OPC server directly connect to its SCADA OPC to receive the live data feeds, and or you can also import the historical data like Excel, Access, DBases, and that the integrations like OPC server actually works with the SCADA Connect simulator that I have showcased. Okay, so that is the thing. But as an example, the Darwin calibrator I have showcased. So SCADA data imported via SCADA Connect can be used in Darwin calibrator to adjust model demand patterns and boundary overrides, and the pipe roughness to match the how with the reality it changes. But the SCADA simulators is the thing where you can make the real-time data available. Okay. Or if you have historical data, you can directly show this.
Okay. Thank you, Deep. Because
What I'm doing, I'm sharing one of that's the modules to that how it actually the SCADA works with the flow chart, so that will be also easy to understand you before. Okay. Okay.
Okay, thank you so much. Yeah, because we understand for monitoring non-revenue water is not easy because we need check all the data, and then is there any anomaly for our calibration or our staff
Right.
to monitor that kind of the data before we prepare the project? Because
Right.
to
If
replace
you have
the
historical data,
pipeline.
you can directly make it
Okay.
for that.
Okay, thank you
Right.
so
With the
much.
SCADA element, you can make that the connections and do that. So I'm sharing one of that our tutorials for you, so you can also have a look. Okay.
Okay, thank you so much.
Makasih, Pak Rido. There is a questions on the chat, Deputy. Let me try to translate it for you. So this is from Pak Rizky from Perum Air Berau. So you're trying to ask that what they should prepare, any type data or maybe hardware they need to prepare to build some systems that digitize, as you mentioned, so digital twins, or can we do the customizations according to their readiness data or hardware on the sites? So maybe you can elaborate on that point.
Absolutely. That I have showcased. You can do the customizations and like what the data you need in digital twins. That depends upon you. That what you want to get to showcase. And the sensors data that I have already mentioned with the SCADA Connect simulators, you can make it available. But with the digital twins, that also works with that servers and datas that you have, the sensor datas for the applications you are using. We need to just check. But globally, this application has been used, and it's not like a huge things you need to do. You need data loggers, and you have to manage that, how you just put that informations with that water site. Okay. But the SCADA Connect simulators were helps with the OPC servers. Okay.
Oke, jadi Pak Rizky sebenarnya yang penting dipersiapkan adalah adanya pertama data dari Bapak sekaligus model dari hidrolik daripada sistem Bapak yang menambahkan value saat Bapak melakukan integrasi digital twin adalah ada sensor-sensor yang bisa memberikan informasi secara real time atau near real time kepada tim di command center apa yang terjadi sesuatu di sistem distribusi airnya Bapak. Jadi Bapak perlu data modelnya, kemudian Bapak juga perlu sensor-sensor yang bisa memantau kondisi secara near real time di lapangan. Kira-kira begitu. Oke, Bapak Ibu sekalian ada yang mau bertanya lagi? Kalau misalkan tidak bisa on cam atau ngobrol langsung, bisa langsung paste di chat ya. I saw the content, the previous questions, Jyoti, that is these materials for the presentations later that you share can be shared with the audience?
Yeah. We will share that the videos.
Iya. So, jadi Bapak Ibu semua
This is recorded session, right? So they can
oke.
also have a okay. So
Jadi recording dan materi nanti yang akan dibagikan kepada setiap peserta setelah selesai acara webinar kita. Ada pertanyaan lagi, Bapak Ibu sekalian? Oke. Kalau misalkan tidak ada pertanyaan lagi, atau baru nanti kepikiran setelah selesai sesi bisa langsung hubungi Bu Nesi atau bisa langsung email juga nanti ke Deep Jyoti atau Jamie Hao supaya bisa direspon apapun pertanyaannya Bapak Ibu sekalian. So we're gonna share your contacts and Bu Nesi as well, Deep Jyoti and Jamie Hao for all of the attendees for them to submit their questions. Oh, satu lagi Pak Kuerendra. Silakan Pak Kuerendra.
Sorry, bahasa ya. Kalau
Silakan Pak.
open flow ini, Mas, kalau tiren itu pengaruh nggak ya untuk
Tiring.
jaringannya itu? Iya, tiren. Jadi misalnya konturnya itu naik turun itu
Mhm.
pengaruh nggak ke ininya? Soalnya karena kita misalnya kita nggak ada data kontur nih untuk jaringan itu pompa dan itunya itu pengaruh nggak?
Oke.
Data itu perlu nggak sebenarnya? Itu aja.
Sip.
Makasih.
Makasih Pak Kuerendra. So questions for Pak Kuerendra Deep Jyoti is how the terrain can affect those digital twins or the simulations. So because sometimes they don't have the terrains, the elevation, slope, elevation of their pipings. So
But
how important that's
obviously, if you don't have that terrains, how you will create that gravity-based networks? You must have the terrain. So you may have the contour maps, or you may have the GIS. From the GIS, you can create. Okay. So what is the elevation? So if you don't have that elevations, you could not create that water network model even, right? So that is the elevations on only one of the things that how that water flows. So you need that. So for that, what you may happen that you can create the contour maps from, if you have some contour points, then you can create the contour maps through OpenFlows Water, or you can have the GIS from QGIS, ArcGIS, anything. You can just make that elevations and can be used there. Okay.
Sorry, Deep Jyoti, is it the GIS things? Is it included in the OpenFlows, or they need to buy
GIS is
separate?
you can integrate ArcGIS Pro with OpenFlows Water, but you could not have the GIS, but you can use any of the free GIS applications too, like QGIS, any other GIS applications to create those. No issues with that. The shape files could be used, or DXF file could be used, or land XML data, DTM data, anything. But
Okay.
the elevations means the contours is needed if you do even the modeling.
Okay.
All right.
Thank you.
You can put
Thank
that
you.
thing manually, but it's needed from the survey data or something somewhere else. Yeah, you need that. Either you could not make that network, right?
Okay. Thank you, Deep Jyoti. So saya kira
Oke.
memang menjawab Pak Kuerendra. Jadi memang kalau misalkan Bapak nggak punya data ininya, JS-nya Bapak bisa integrasikan dengan aplikasi JS, atau mungkin ada shape file JS data atau DTM Terrains model kita bisa gunakan untuk
Oke.
pemodelan.
Iya, terima kasih.
Sama-sama Pak. Ada lagi Bapak Ibu?
Pak,
Yang tinggal.
boleh tanya Pak?
Silakan
Yes.
Pak. Ya silakan
Ya,
Pak.
saya Irawan Pak dari APJ Jakarta.
Oke.
Saya mau nanya, kita pernah membuat satu modeling sesuai dengan parameter semua kita masukkan, dan kita running sesuai dengan modeling, tapi aktual di lapangan kok berbeda, sehingga kita harus melakukan kalibrasi untuk menyesuaikan kondisi di lapangan. Nah, itu disebabkan oleh apa banyaknya? Apakah parameter yang kita masukkan salah atau kurang tepat, seperti itu? Itu banyak sekali, bukan area yang
Itu
besar
Bapak
saja.
melakukan modeling pakai apa Pak ya? Kalau boleh tahu.
Aduh, lupa pakai.
Bukan OpenFlows ya?
Apa Pak?
Bukan
Dari
OpenFlows.
Australia.
Oh, dari
Iya.
Australia. Okay.
Yeah.
Thank you. Makasih Pak Irawan. So
another
question, Deep Jyoti, from Pak Irawan. So he said that they ever tried to do the modeling simulation using the parameters they capture on the sites. They do the simulations, and then unfortunately the result is not as happened on the sites. They are not using our products, but perhaps you can advise what makes these simulations can be differ with the actual happening on the sites, and what's the critical informations or data they need to verify calibrate to have a better result?
Yeah, that is the thing that as you have asked, right? If we don't have like if we don't have the elevations, what will happen? So how you are creating these elevations, or that usually when you do the water network, we have the road center line. Okay, from that we create the network. So how much data's input you have strong, you can create a good models. So that is the thing that differs. How you are distributing the loading, the demands patterns. So you are distributing the demand patterns haphazardly or just by your own. So that's is needed. So you need to take care about that's how you are just choosing the right methodology or not. But I can assure you this open flows water used globally. So that is the only solutions. Open flows waters. If you just go for that water resource or water network models, everyone uses water gems, and it has a use. I mean, you don't need to worry about that accuracy because it works as you want. Means you can just customize that roughness coefficients and can do that's what you want. You can go with a different diameter set. So what happened that in the executions they are not placing you may not getting that the elevations in correct way, that the tank level is not that what you are getting. We can have a brief discussions on it if I get to see your models and what happens specifically in a separate calls too. Okay, and can have a better understanding that where you are getting stuck. Okay, so then you can also go with our applications softwares and can highlight on it. Okay.
So in our open flows, do we have something like data calibrations prior, right? To make sure that get the better results.
Yeah,
yes?
Obviously, that I have already showcased that the calibrations, that calibrated tool is already there. You can do the calibrations thing very easily with that.
Okay.
With the field data, what you have and what is the observed data, you can compare and take the best decisions that what need to be changed.
Oke, jadi Pak Irawan, hasilnya bisa jadi karena pertama datanya Bapak mungkin perlu dikalibrasi sebelum di running simulasi akhir, dan biasanya itu terjadi karena memang parameter Bapak yang mungkin ada yang tidak tepat
Kurang
gitu.
tepat ya.
Ya, kurang tepat. Jadi kalau misalkan Bapak di kita itu ada di prosesnya ada data kalibrasi hydraulic models-nya. Nah, kalau misalkan Bapak tertarik mau dicoba dilihat, DeepJT bisa terbuka untuk bisa membantu Bapak ke depan. Bagaimana? Kira-kira gitu, Pak
Oke.
Irawan.
Iya, karena sering terjadi perdebatan antara tim modeling dan tim
lapangan ya, Pak.
operasional di lapangan.
Ya.
Jadi dari sosnya butuh tekanan sekian, ternyata nggak nyampe juga sampai ke titik kritikalnya nggak nyampe, nggak sesuai dengan modeling seperti itu.
Kalau pengalaman kita biasanya hydraulic modelnya yang kurang tepat sih itu Pak, parameternya. Jadi memang harus dikalibrasi dulu hydraulic modelnya sih.
Ya.
Banyak user kita biasanya kendalanya di situ.
Iya. Kita pakai ArcGIS dulu, pakai modelingnya. Oke, terima kasih Pak Julius.
Terima kasih, Pak Irawan.
Thank you, Pak.
Oke. Ada lagi Bapak Ibu?
I have shared few of the links that may help you to understand much more in better ways. Okay, so you can have a look later. So,
okay. Ya, Bapak Ibu, ada beberapa informasi tambahan yang diberikan oleh DeepJT. Ada link yang bisa dibaca-baca, khususnya untuk yang kalibrasi data hydrauliknya, sekaligus sistem bagaimana sebenarnya data apa aja yang dipakai di membuat digital twins yang sudah dipaparkan sebelumnya. Oke. Kita masih ada pertanyaan lain. Kalau misalkan tidak ada, kita tutup dalam 1, 2, 3. Saya kembalikan ke Bu Nesi.
Terima kasih Pak Junius. Hadirin yang kami hormati, mengingat keterbatasan waktu, demikianlah rangkaian webinar pada hari ini. Thank you so much, Dip, Jamie, Pak Junius. Terima kasih. Terima kasih kepada seluruh peserta atas partisipasi dan pertanyaan yang diberikan. Apabila Bapak dan Ibu ingin mencoba software OpenFlows, Eva License dapat menghubungi saya. Atas nama Kurnia Handasa Nevada, mohon maaf apabila ada hal-hal yang kurang berkenan. Sampai jumpa di sesi webinar yang ketiga dengan tema Transitioning to 24/7 Continuous Water Supply minggu depan 13 Mei 2026 jam 10. Semoga materi yang telah disampaikan dapat memberikan manfaat dan menambah wawasan kita semua. Terima kasih semuanya. Sampai jumpa minggu depan. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih semua.
Waalaikumsalam. Terima kasih semua.
Terima
Thank you.
Thank
Terima
you.
kasih.
Thank you.
Terima kasih.
Thank you.
Thank you.
Thanks, everyone.
Thank you.